Okay, this is our study guide for parallel lines and transversals. So the first section here just wants us to identify. So 2 and 6 are here. So those are on alternate sides of the transversal, and they're in between the two lines. So since they're alternate sides of the transversal and inside, it's going to be alternate interior. They're alternate interior angles. Next pair is 1 and 9. These are corresponding. They're in the same corresponding location. If you pick this up and put it on top of the other one, they're going to be 9 is going to be on top of 1. They're in the corresponding location, so they're corresponding angles. 9 and 6. So this is a none. We don't have an angle relationship here. Vertical and linear are formed at the same intersection point. The corresponding alternate interior, alternate exterior, and same side interior are formed by a transversal cutting through two lines. We don't have a transversal that goes through both of these points. It cuts two lines. So it's a none. 9 and 13. 9 and 13. Those are alternate sides of the transversal. They're outside of the two lines, so they're alternate exterior. 14 and 16. Okay, those again are corresponding, same corresponding location. If you pick up that intersection point and put it on this one, 14 would be on top of 16, so they're corresponding. Ten and 16 are vertical, and they share the same vertex, so it's either vertical or linear. They're across from each other, so it's vertical. Okay, 2 and 1 are a linear pair. Okay, they share the same vertex. They're right next to each other, same intersection point. They're going to be a linear pair. Okay, 10 and 14. These are on alternate sides of the transversal, and they're in between the two lines, so that's alternate interior. Okay, 11 and 6. Same side of the transversal, and they're in between the two lines, so that's same side interior or consecutive interior. Again, same side interior is the same thing as consecutive interior. Okay, 15 and 11, those are on opposite sides of the transversal. And they're in between two lines, so that's alternate interior. Okay, 4 and 13. They're on the same side and they're both outside, so that's same side exterior. But we haven't used that one or talked about that one, so we're just going to say none. Okay, but if you put same side exterior, that would be fine. And then 3 and 11 are corresponding. 3 and 11 are corresponding. Correspond. So let's go down to the next section. So it's telling us that the measure of angle 2 is 58. 58. And the measure of angle 13 is 111. I want to find the measure of all the missing angles. We know that X and M are parallel. Well, let's use green. X and M are parallel. We also know Z and Y are parallel. Okay. So first thing I want to do is our vertical angles in our linear pair. So let's look here. These are vertical, angle 2 and angle 11 are vertical, and we know all vertical angles are congruent. So if the measure of angle 2 is 58, the measure of angle 11 is also 58. And then we have linear pairs. So we know that these two are supplementary angles, because linear pairs are supplementary. So we do 180 minus 58, that gives us 122. And then these are vertical, so this is 122. I know these are vertical, so this is 111. I know these are a linear pair, so we do 180 minus 111. That gives us 69. Vertical again, so 14 here is 69. If I look at this one, we know these two lines are parallel. So these are corresponding angles, okay, but they're not congruent because those two lines are not parallel. In order for corresponding angles to be congruent, or same side interior angles to be congruent, or same side, in order for corresponding angles, alternate interior angles, or alternate exterior angles to be congruent, the lines need to be parallel, like these. Okay, if they're not parallel, then we have nothing to say about them. We don't know. So angle 2 and angle 4 are not congruent. They're different angle measures. But 2 and 16 would be corresponding, so they're going to be congruent, so that's going to be 58. And then we know vertical is 58, and we know linear pairs are 180, so this is 122 and 122. We have 15 down here, but we don't know that one yet, so let's hold on to that one. We'll do that one at the end. It's going to end up being alternate interior with 6, right? It's also corresponding with 9, so we either need to find 6 or 9 first before we can find 15. Okay, so let's try to get up to this intersection point. So right now we have the only one where it's not split up would be 8 and 5. So we know 2 and 8 are corresponding, so this is going to be 58, right? Or these would be corresponding, or alternate interior. So these two are going to be 58. Okay. And then these ones are split up. So we know that these two added together are 122. And we know that these added together are 122. But we got to use something else. How about this transversal here? So we know angle 3 and angle 7 are alternate interior. Or we know that 3 and 10 are corresponding. So we know this is going to be 69 and this is going to be 69. The last one, again, so this is 122. So that means these two added together have to be 122. So we can do 122 minus 69. The other way we can look at it is all three of these have to add up to 180 because this is a straight angle. So we can do 180 minus 69 minus 58, and that's going to give us 53. So this one is 53. And then we have vertical, so that's 53. And then 6 and 15 are alternate interior angles. 15 and 9 are corresponding angles, and these two lines are parallel. So this one is going to be 53. Okay. Let's go to the next one. Okay, the next one's we want to find the values of x and y. Okay, we can zoom in probably a little. So here we have two parallel lines. These arrows tell us they're parallel. These are a linear pair. We know linear pairs are supplementary, so they add up to 180. So we can do 3x plus 5 plus 6x minus 14 equals 180. We can solve for x. Okay, we also have corresponding angles here. So we know that 3x plus 5 is going to equal y plus 8. Or we could have done 6x minus 14 plus y plus 8 equals 180. That would have worked too. So let's use our first equation to find x, substitute it in, and then we can find y. So combine like terms, that's going to be 9x minus 9 equals 180. We add 9 to both sides. we get 9x equals 189. We divide by 9, we get x equals 21. Right, we substitute in 21 here for x. So we have 3 times 21 plus 5 equals y plus 8. That's going to be 63 plus 5 equals y plus 8. That's 68. And we subtract 8 from both sides, and we get 60 equals y. So x is 21, y is 60. Let's do 30. Okay, do 30. These two angles are these lines are parallel. Okay, these two angles are corresponding angles, so that means this one is 90 as well. So corresponding angles are congruent if the lines are parallel, so it's going to be 5x equals 90. Divided by 5 means x is going to be equal to 15. I'm sorry, x is going to be equal to 18. Okay, and then these are a linear pair. So 5x plus 9y is going to be 180. So 5 times 18, we're going to substitute this in. Plus 9y is 180. So this is going to be 90 plus 9y equals 180. We subtract 90. We get 9y equals 90. We divide by 9. And we get y equals 10. Okay, good. Go to the next one. Okay. So here's our parallel lines. So we know these are, again, here's our transversal. So these angles right here are same side interior angles. So we know same side interior angles are supplementary when the lines are parallel. So this is going to be 8x plus 40 plus 6x equals 180. Hey, combine like terms, this is going to be 14x plus 40 equals 180. We subtract 40 from both sides, and we get 14x equals 140. Divide by 14, and x is going to be equal to 10. We can substitute back in to check. That's going to be 60, 120. That's good. Our other equation then, here's our other transversal. These are same side interior as well. So we're going to have 7y plus 3y minus 10 equals 180. Same side interior angles are supplementary, meaning they add up to 180. Combine like terms. That's 10y minus 10. So add 10. 10y is 90, 190. Divide 10. Y is 19. Let's look at 32. Okay, these are corresponding angles. The lines are parallel. Since the lines are parallel, corresponding angles are congruent, so we know we have 3x minus 15 is going to be equal to 2x plus 7. Subtract 2x from both sides. We get x minus 15 equals 7. Add 15 to both sides. We get x equals 22. We can substitute it back in to check. So this would be 66 minus 15 is 51. This would be 44 plus 7 is also 51. 33. So let's start with our 72 here. So these angles are supplementary, right? We have our lines are parallel. So those are same side interior angles are supplementary, so they add up to 180. So we're going to have x plus 72 equals 180 minus 72 minus 72. X is going to be 108. We know these are a linear pair, so 3y plus 72 is going to equal 180. We can subtract 72 from both sides. We get 3y equals 108, and then we can divide by 3. Y is going to be 36. 3 goes into 90 30 times, and then it goes into 18 6 times. So that's got to be 36. Now we need z. So these are corresponding angles. So 3z plus 18 is going to equal x. We know x is equal to 108. So we can subtract 18 and then divide by 3. So that's going to be 90. We divide by 3. Z is going to be equal to 30. Thirty-four. These two angles are corresponding. So since these lines are parallel, we know corresponding angles are congruent. So since this one is 90, that's what the right angle symbol means. This one is also 90, so x is going to equal 90. Okay, so this is 90. Here we have parallel lines. So these two angles are same side interior, so they're going to be supplementary. They add up to 180. So y minus 18 plus y plus 12 equals 180. Okay, so that's 2y minus 6 equals 180. Add 6 both sides. That's 186. Divide by 2. Divide by 2. Y is going to be 93. So we can substitute that then in here. So 93 minus 18 is going to be 75. Okay, and we know this is a straight angle. So these three angles are going to add up to 180. So 90 plus 75 plus z are going to equal 180. Combine like terms, that's going to be 165 plus z equals 180 minus 165. Z is going to be equal to 15. Straightforward. Next section, the lines are parallel. So it's L and M. This is L and M. Okay, they are parallel. Find the measure of each angle. So the measure of angle 7 is 100. Okay, and then we want to find 3. So 3 and 7 are alternate interior angles. We can use the alternate interior angle theorem to tell us that if the lines are parallel, which they are, then the alternate interior angles are congruent, and congruent means their measures are equal. So this is also going to be 100. Okay. Next one. 7 and 6. Okay, these are same side interior angles. Same side of the transversal in between the two lines. Since the lines are parallel, the same side interior angles are supplementary. So they're going to add up to 180. So we have to do 180 minus 175, which is going to give us 5 degrees. Next one is 7 and 5. Okay, those are corresponding angles. Since the lines are parallel, we know the corresponding angles are going to be congruent. So the measure of angle 5 is going to be the same as the measure of angle 7, which is 120 degrees. Our next one is 4 and 7. We don't have a direct angle pair that relates 4 to 7, so we have to go indirectly. So we know the measure of angle 4 is 20. We know 4 and 6 are vertical. So that one, angle 6, the measure of angle 6 is also going to be 20. And then we have same side interior angles here. Same side interior angles are supplementary when the lines are parallel. So we're going to do 180 minus 20, which is going to be 160. Okay, 3 and 8. Again, we don't have a way to connect those directly. So we have to go indirectly. So let's do alternate interior. Corresponding, let's do corresponding. So we know corresponding angles are congruent if the lines are parallel. So the measures of angle 3 and angle 1 are going to be the same. So this one's going to be 140. And then these are our linear pair. We know linear pairs are supplementary. So we're going to do 180 minus 140, and that's going to give us 40. Okay, the measure of angle 4 and 1. So we're looking at 4 and 1. So this is 30. We don't have an angle pair for that. So let's use corresponding. So what corresponds with 4? It's going to be 2. So the measure, these two are going to be congruent, so their measures are going to be equal. Then again, we have a linear pair. So linear pairs are supplementary. They add up to 180. So we do 180 minus 30, 150. 41, we're looking at 4 and 2. Okay, those are corresponding angles. So they're congruent if the lines are parallel. So the measure of angle 2 is 40. Okay, and then 7 and 4. So 7 is 125. We have to go indirectly. So those are alternate interior with 3. So this is 125, and then that's supplementary because they're linear pairs. So 180 minus 125 is going to be 55. Okay, I'm going to keep going. I'm going to do all this stuff before the proofs on this one. So it wants us to identify the angles that go with each of the following. So corresponding angles. So angle 4 is going to correspond with angle 5. Angle 3 is going to correspond with angle 6. Angle 1 is going to correspond with angle 8, and angle 2 is going to correspond with angle 7. Okay, alternate exterior, angle 4 and angle 7 are alternate exterior. And then angle 1 and angle 6. Okay, they're on alternate sides of the transversal. Here's our transversal. Alternate sides, and they're outside the two lines. That's alternate exteriors. Consecutive interior is same side interior. So we're looking for the same side of the transversal and in between the two lines. So 2 and 8 are on the same side of the transversal and in between the two lines. So we can do angle 2 and angle 8, or we can do angle 3 and angle 5. Alternate interior angles, so we're on alternate sides of the transversal in between the two lines. So 2 and 5, or 3 and 8. Okay. Next section, we want to name what the transversal is, and again, use our special name, our angle pair name. Okay, so 1 and 12. Here's our transversal. So our transversals are, and 1 and 12 are alternate exterior. They're on alternate sides of that transversal, and they're outside of the two lines. That's alternate exterior. 2 and 10, this transversal is still going to be R, and they're in corresponding locations. They're both on the same side. One's inside, one's outside, though. Or you can think of it as picking this one up and putting it on top of the other one. 10 would fall on 2, so 10 and 2 are corresponding. 4, 9. Again, we're using R as our transversal. Okay, these are alternate sides of the transversal, and they're in between the two lines, so that's alternate interior. 6 and 3. So this time we have a different transversal. So our transversal now is going to be M. We're looking at 6 and 3. They're on alternate sides of that transversal, and they're outside of the two lines. They're outside of R and T, so they're going to be alternate exterior. 14 and 10 are down here, so our new transversal for this one is going to be K. They are in corresponding locations, so they're going to be corresponding. Transversal is K, corresponding. Okay, and then 7 and 13 are transversal. Again, we got to switch over to the line that goes through both 7 and 13. That's going to be RT. And those are on the same side of the transversal, and they're in between the two lines. They're in between M and K, so they're same side interior, or consecutive interior. Same side interior. Also known as consecutive interior. Okay, and then we got one more section before the proofs. I'll do the proofs on a different video. Yeah, I'll do the proofs on a different video. We got 5 proofs there. We'll do a different video. Okay. So in the figure below, A is parallel to B. The measure of angle 1 is 78. The measure of angle 2 is 47. We're going to find the measure of all the angles. So again, let's really look for vertical and linear first. So I'm not going to worry about this right now. Let's just fill in what we have. So this is 47. We know this is vertical, so that's 47. We know this is a linear pair, so that's 180 minus 47, which is going to be 133. Okay. Here we have linear pairs, so 180 minus 78 is going to be 102. And then we have vertical, so that's 102. Okay. The lines that are parallel are A and B. So if I could draw in here. Here's our parallel lines. So 1 and 5 are corresponding. So this is 78. Because the lines are parallel, we know that our corresponding angles are congruent. And then this one's corresponding, so this one's 102. And then we can do the same thing up here. So corresponding here, so this is 47. Alternate exterior here, so this is 133, or you could do linear pair. So we could fill them all in if we want to. This one, the measure of angle 3 was 102. 4 was 102. 5 was 78. 133. 47. 47. 133. And 102. Okay, so that's all the problems on the review that are not proofs. There'll be a separate video that I'll do for proofs. It'll take a little bit of time.